Τώρα θα συνδεθούμε με τη Χαβάη, όπου βρίσκεται ο opening keynote speaker μας, ο Joe Justice, Chair of the Board of Directors του Agile Business Institute και Board Member του Boston University Agile Innovation Lab, ο οποίος θα εστιάσει στον τρόπο εφαρμογής της μεθοδολογίας Agile στην Tesla. Mr. Justice, thank you very much for being here with us in such an hour. It must be very late for you. And the digital stage is yours.
Thank you so much. It is my honor. Is my audio coming through okay?
Yes, we hear you perfectly.
Perfect. Okay. It was wonderful to hear from PMI Greece. It was wonderful to hear from the Agile transformation experts at McKinsey. What could I possibly add to this? I did learn some things in Tesla that might be exciting, and I'd like to share. I did enable a picture screen sharing. I don't know if it's coming up. Perfect, if that's all right.
Yeah.
Here's a picture of me heading into the mothership, we call it, the Fremont, California Tesla Factory and Design Center. And to keep myself on time, I'm going to give myself a max of 15 minutes to talk to make sure I can field whatever questions people may have. Tesla is the fastest company I've ever had a part of. I took an aerial photograph of Tesla and my daily diary. I kept a diary every day working there, operating the Agile program. And I overlaid my diary and edited it on the floor plan of the factory so I could remember the speed that it operates. And where I'd like us to start is when you first enter the Tesla factory. I'll zoom out a little bit so we can maybe see that it's a factory. This is the factory floor plan. You drive, if you follow my mouse pointer, on a road here called Cato Road. Cato Road is in the news now often for new battery development and new battery production. It's arguably the fastest iterating battery development and design and production in the world right now is along Cato Road. And that's how you drive in to enter the factory. Then you hand your car to a valet. If you drive an electric car, any brand of electric car, they'll charge it for you while you work. And it's a very beautiful valet tent. It's a gray, calling it a tent doesn't sound nice enough, maybe gazebo. It looks like you pulled into a resort. And they'll take your car and park and charge it for you, and then you go past the coffee, and it's arguably, they try to make the world's best coffee. You can pick the roast you'd like, the grind you'd like, you can pick the espresso drink you'd like. And the point I'm trying to make here is how flat the organization feels. Everyone gets this treatment, whether you came in to clean the floor or you came in to help certify cars. You have valet and gourmet coffee, and you walk in through what's labeled here on the aerial photograph as the office, but there's no office. There's the coffee service, and there's help desk where you can drop off a laptop or a phone, and they'll just hand you another one while they figure out what's wrong. It's very fast. But that's it. It's not like there's anyone sitting in cubicle farms or even collaborative workspaces. Not at all. You go directly into the factory. And the first thing you see once you pass the coffee and enter the factory proper is what's called the bamboo line. Here's a picture of it. Tesla works in sprints as short as 3 hours, introducing new hardware into production. That means there's new electronics in the cars, new shapes of metal, new metal alloys, new software, of course, all day. Every 3 hours, and in some cases even faster. What that also means is that the traditional certification process for cars is not nearly fast enough. That's often more than a year long to homologate, test, and certify one type of car. And that's what reduces the speed of most car makers. They couldn't introduce new car designs faster than the certification and approval process. So Tesla did what nimble software companies do. They automated the test. This is actually what autopilot comes from. It's called factory mode. And what factory mode is every single car, from the moment it's put together, puts itself through all road legal certification tests, the non-destructive ones. They don't crash themselves. That's simulated, running on big monitors above the cars and in the cloud. Every car is individually certified for production because every single car is potentially unique. That is what DevOps in hardware looks like. And of course, SpaceX does exactly the same thing. And they have long-running automated hardware tests. These are rocket manifolds going through continuous integration and continuous CI/CD, because SpaceX now produces new rocket engines, new designs, every 2 days. They go from design in CAD to test-fired and on a rocket in 2 days. Tesla's even a little faster in cars, but in rockets, that's an absurd speed. We run retrospectives just like anybody else, or furikaide in Japanese. And we use those to accelerate and focus on team happiness. What may be unusual is retrospectives directly result in new job postings. Teams will run their own retrospectives, and then they will post job postings themselves. In fact, that's how I was hired. A job posting was put up by someone in Tesla, not some senior person. It's essentially flat. There aren't really senior people. Saying, I think we'd be even faster and more efficient if we had something like this. And I responded, and that same person interviewed me. And they signed their name to say, let's bring this person in. And that's the way all hires work in Tesla. What I think might be useful to know next is what slows down hardware companies the most. And what it appears to be from my operations in Tesla is they have a large cost to change in traditional hardware manufacturing. So they want to reduce the change cycle because it's expensive. There's a dependency order of ripple effects through the supply chain and through suppliers. That then exacerbates, even makes it even worse, waiting on third-party testing, et cetera, et cetera, et cetera. So in Tesla, we do use the extreme manufacturing practices, which is part of what I was doing when I was in Tesla. Things like modular design, test-driven development, line setup, optimized for change, agile hardware design patterns, continuous deployment. It's what we've known in software since the 80s or earlier. Well, this is revolutionizing manufacturing now. So how does that work with suppliers? I was working in a team, and the teams are on change as often as you want to. It's run like an open space. You go to wherever you think you can add value in software or machine learning or in programming robots or in loading metal into robots or getting a robot unjammed, painting, configuring machine learning to assess painting. Wherever you think you can add value, you just go there. So the teams are completely unstable, but that's by choice. You can choose to stay in the same team forever, for years, if you'd like. But typically, when a team reaches a definition of done, a release, so about every 3 hours, if you're lucky, if it's running well, then you could decide, is this the highest value place for you to go? And you decide to move on or not. I was in a team, and Model 3s and Model S's, and Model X's, and Model Y's are entering our team cell. And we did our value-added steps and our innovation and our continuous improvements and our design and our installs. And then it's automatically tested by robotic vision and machine learning stacks. Did we meet a definition of done? And we get that feedback. It's not like it goes to some manager. There really aren't managers. The teams are responsible for their own improvements. So you have an efficiency metric of how quickly you're able to efficiently spend money. This is maybe important. There's no budgeting. There's no concept of a 9-year budget. There's no leadership model like that. It'd be way too slow and way too not agile. I mean, if you're making a 9-year funding plan, how can you account for a chip shortage tomorrow? You can't. You miss the benefits of agility. So there is no budget. Instead, there's a real-time visualization of how much money is left in the company. We call that runway. And then every team is measured on how quickly they can spend money. And from the minute you're hired, you have authority to spend money, lots of money. And you want to spend it as fast as you can, efficiently. So there's wonderful machine learning stacks to try to help you see, are you being more efficient than the company was minutes ago? And if so, then you have measure that everyone can see. It's on your phone, it's on all the monitors for everyone, that says how efficiently is capital being expended. And you self-manage on that number. So our teams are managing that way, and cars are going by. And all the cars are made out of a series of stamped panels at the chassis level, at the frame. This is called the body in white, and every car all over the world is made this way. They're made out of a set of stamped or formed panels, and those are welded together or bonded together or riveted together. Every BMW, every Mercedes, every Toyota, every Ford, every Stellantis group vehicle is made this way. Then a car flowed by, and the rear third of it looked like this. It was made like a giant toy car. It was a casting. It was like someone squished Play-Doh, metal Play-Doh, into a mold and popped out the entire third of a car at once. Now, this is what you wish you could do. It's cheaper, it's faster, it's lighter, it's safer. This is what you wish you could do. And no one has been able to make castings fast enough for production of this size before, ever. And the reason behind that, we can go into the questions and answers if that's what's most interesting to you. And a car came with this. No one told me it was coming. No one told the team it was coming. The machine learning stack analyzed it visually and said it meets the definition of ready. It doesn't say it. It's a heat map. It's mostly purple, which is a good thing. And that meant we should be able to work with it. So it flows in. We do our value-added steps. It meets the definition of done, and it's sold. Oh, okay. I thought there was a note to me. Sorry. And that car goes off to a customer. The next car comes, it looks like this again. Because remember, there's 3-hour or less sprints with changes. And this sprint went actually even faster. Every 45 minutes, we got a new casting with a different experiment to improve the speed of casting, the safety, the net effect safety after the fact, with different fill lines, ribs, reinforcements, different structures. Every 45 minutes, we're getting a different casting. Now, typically, castings, if you do them at all, or stampings, change every 3 to 7 years because they're tens of millions of euro for a die set, a casting set. So you would never change them. And so change control processes are put in ahead of them to make sure we've tested and tested and tested again so we don't have to make another casting. Well, Tesla doesn't do that at all. That would block the speed of innovation. So instead, they fund making a new casting as fast as they possibly can. Remember, there's no budgeting. It's about the burn rate. You want to burn through your runway efficiently as fast as you can. So these new castings are arriving every 45 minutes, and then front castings start to arrive, and then stressed battery packs, which those of you who attended the Giga Berlin unveil have seen. Now that's public information. Now it's in the public domain because it was unveiled at Giga Berlin. These were just rolled out. And as the factories are being built, these castings are being tested and iterated. So the cars are structurally changing inside 45 minutes in production. These aren't test vehicles. These are going out to be sold. And the reason this happens is because of the way Tesla works with suppliers. In Tesla, the hardware in production changes about every 3 hours. That includes hardware provided by some suppliers, some in Italy. We then visit, I've shown you some of the casting and stamping operations, and it's driven by the contract. The contract for a supplier at Tesla will state, we would like an updated version on a cadence. If it's a new supplier that's new to Agile, the cadence, which is how it started for these castings, is once a year. And the casting design and build companies love it because they have a stable contract. They get to make design, manufacture, test, and deploy a new casting once a year. Well, that worked. So Tesla increased the speed. They said, we'd like a new one once a quarter, once every 3 months. And the supplier panicked. They said, yes, I think we can. We'll need to dedicate a full stack team to design, machine, test, and deliver this casting, and they'll only work for you, Tesla, because they won't have time to work on anything else. And that worked. So now they were hitting once a quarter, making die sets for stamping, actually. Then Tesla said we'd like them once a week. And this supplier said the only way we could possibly do that is if we fly to the Fremont, California mothership sit down on the floor next to the stamping machines and then next to the casting machines, the GigaCast, and work on our laptops, and we design the next casting and die set while we're machining the current one. And as soon as the current die set is machined, we install it in the stamping machines or the GigaPress and immediately start machining the next die set. That's the only way we could possibly do it. And Tesla said, well, great, do it. And that's how I met this supplier. They were sitting in a ring on the floor. There are almost no chairs in Tesla. I never attended a meeting in chairs ever. I never saw a presentation ever. I definitely didn't ever see a budgeting session. Instead, people sit on the floor or stand with laptops next to the machines, so you have immediate feedback next to the supplies. And this team, once they were working in this level of Agile, they were actually able to do it every 45 minutes because that was the maximum speed of all of the machines combined running together to make die sets and install those. So I was able to talk about a flat organization with a dramatic respect for people, with the valet and coffee as examples, but it permeates throughout. There really is no leadership. There's no corporate ladder to climb. There's no junior or senior or anything. Once you're inside, you're just an employee, no matter what you were hired as. Then I showed automated testing, which is what makes the bottleneck go away to speed of release and production. I did show the extreme manufacturing practices to allow engineering and production to go at this speed. And then I did show how Tesla works with contracts. I didn't get to cover estimation, codings, chemical operations, pilot lines, the maintenance model, but I'd love to at another time, if that makes sense. I'm Joe Justice. I operated the Agile at Tesla groups, and I'm thrilled to be a part of this event to share with you I hope the most exciting of what I learned at Tesla. I think I have a maximum of another 6 minutes and 15 seconds. If there are questions, I'm happy to take them.
Thank you very much, Mr. Justice. Incredible presentation, and thank you for being so punctual. In fact, there are some questions for you. Can you describe how the project Wikispeed helped you and your team to design a new car in 3 months?
Thank you so much for the question. So actually, if I can share again, I'll show a picture that might help describe that. Thank you. Thank you. Wikispeed was my hobby company that started in 2006 to try to make cars. And I used Agile methods because I didn't know anything else, and it worked. We would even build cars at Agile conferences. We'd put Post-it notes on the wall and lay a bunch of materials and tools on the ground and put a bunch of beer down and say, let's have a beer and try to build a car. And we would. We built one at Agile Testing Days in Potsdam, Germany. We then raced on the Nürburgring, and I was co-captain of a race team there. And we won the 24 Hours of Nürburgring V6 class in 2014. Now that was a car that we used Agile sprints to make it a race car. It was a BMW M3 CSL. Here's what it looked like. What I learned that is closer to how Tesla started is if you limit the materials to materials you can work with in less than a day, you can design, manufacture, and test in less than a day, you can go really fast. So the first cars were all made out of aluminum tubes because we could cut those and bolt them together and test them in 45 minutes. And we could sprint the shape of the car, the chassis. And then we would make these carbon fiber bodies. And in the beginning, that took 2 days, but we ended up getting that down with using different resins and different heat ramp profiles to under a day. So we could make the carbon fiber exterior for aerodynamic performance. Here's the first car we sent to Europe. And that's about to get loaded into an airplane. It was airflown into Europe, into Potsdam, Germany. So one thing I learned was limit the materials to what you can work with quickly. Now, Tesla has enough money now that instead of limiting the materials, they innovate new machinery and new alloys. Now they can go much bigger budget than I was. But another principle that's been extremely useful, you might just see it here. There's a standard printer paper sheet taped onto the side of what's called a milling machine. This is what you would use to shape metal, to mill channels in metal or drill holes and make chamfers and that kind of thing. And I learned that you want people to be able to use the law of 2 feet and go anywhere, anytime. It's just so much faster than planning and having departments or anything like that. We grew this to 4,000 people, so we were large enough to have departments, but we didn't have any. Instead, there would be basic instructions, never more than a page, on each machine. And the idea is go up to whatever machine you like, and if you know how to use it, just start using it. There's a backlog of what we need to do, so you can figure out what we need to do. But if you don't know how to use it, raise your hand and ask, is there anyone here that's ever used this machine before? And if someone has, they are your pair. And we would do work in pairs, just like XP, Extreme Programming, has been advocating since the 80s. Now that sense improved into mob and ensemble, and we do everything in mob and ensemble. And when I was in Tesla, I took that there too, although they were using, they didn't call it mob or ensemble, but it is extremely similar. So if you're using mob or ensemble now, you're very similar to what was going on in Tesla. So this concept of walk up simple, where in the shortest number of minutes, you can be adding value to any operation, any engineering, any manufacturing, any procurement, any legal defense, is helpful. And that's aided by the agile concepts of definition of ready and definition of done, which is actually a lot of what I ended up doing in Tesla, and that's then automated by machine learning stacks and machine vision. Did I answer the question, or did I miss the point?
Yes, I think you fully answered the question, and in fact, there is another question for you.
You're very kind. You're very polite. Thank you.
Do you do annual budgets, or do you follow something akin to scaled agile approach?
None of the existing frameworks are fast enough for a company like Tesla, and I don't mean to say they're not awesome, because they are. They have a place. So if any company is not shipping something, hardware, software, financial services, in less than a year, they probably want something like Scaled Agile, which introduces a quarterly cadence and big room planning and trains. But that's way too slow for Tesla, where you're doing hardware and working with suppliers in iterations that are 3 hours or shorter. So for that, you need something that just simply does not exist in most of the world yet. It's definitely not in a book. I did try to put some of it in my latest book, but I'm honestly still trying to comprehend it. But I think my book points the way. So there's no budgeting at all. Instead, it's here's how much cash is left. Here's the runway. Here's the efficiency of the burn rate. And this might help. Here's the actual equation every team uses to self-manage. It's CapEx, or capital expenditure, so that's per day or per unit of time, plus OpEx, or operations expenditure. So that's like amortization and depreciation of all the machinery you're using, the office you're in, your materials cost, your salaries, whatever. So it's your OpEx plus CapEx. And that's divided by the estimate, mostly calculated by machine learning, of the value you added. So if you've increased the efficiency of the heat pump in all the Tesla cars, if you increase the efficiency of the heat pump by 20%, that has a calculable value to the company of Tesla. It increases the range, they have an estimate or a gauge for how much that's worth to the company, etc. That's then offset by the cost it took your team to consume it. And that's it, there's no budget. You just simply try to be more efficient than you were on your last release. And you try to make releases as fast as you humanly can.
I see, and I think if you have 1 or 2 minutes to spare, we received another question. I don't know if you have the time to answer it, or if you're.
I am okay for one more, but I want to be polite to the next speaker and the entire audience. So please let me know if this fits the conference schedule. If it does, I will absolutely make time for another question.
Yes, of course. I think we can afford one more question. How do you overcome the COVID-related problems for like remote working?
So the goal in all the Musk companies, at least when I was there, was you want to be within touching distance of the machine that's going to make what you're designing or procuring for, and the materials. So remote work is possible, but it's highly discouraged. So you're in suits. Like when I was first in Tesla, it's right when COVID was starting, and we didn't know very much about it. So we were in multiple layers of suits, several layers of eye protection, mouth protection. I mean, it was almost like you were going scuba diving. But as a result, you worked co-located with the work where you could. So if you're designing CAD of a heat pump or writing embedded software for a heat pump, you're next to the machine that's making at least part of the heat pump, and you can see all the others. So if that's done at a supplier, you're at the supplier. If that's done in Tesla, you're in Tesla. And the material stack to go into that machine is also right there where you can touch it. And that creates a very fast feedback loop for really good design. It makes it less likely that you design something that's difficult or impossible to manufacture. Also, you're never allowed to only design. You have to also manufacture. So Elon Musk, the richest person on planet Earth right now, arguably, loads robots, carries 20 kilograms, drills metal, paints cars, just like everybody else. And Elon also takes no salary. So unlike Jeff Bezos, who just built a $500 million yacht and is largely checked out, just not directly involved from Amazon or Blue Origin, Elon works, and that creates the flat structure too. I mean, there's no ladder to climb because what, you're going to be like Elon's boss? Good luck, right? So if Elon works 100-hour weeks in the factories, like drilling holes in metal and sweeping and programming robots and writing software and doing CAD, then of course you're going to do it too. It's very inspiring. That plus the non-traditional budgeting, I would argue, is some of Tesla's superpower. And I wonder if other companies will try that approach or not. So overcoming COVID-related problems like remote working, anything that slows the company down is simply removed, whether that's considered traditional or not. So if the idea is remote working, no, because then you're not at the machine. And if that means you need to put on scuba gear, then you're going to put on scuba gear. Now, some things are full remote, like you can have the autopilot hardware anywhere with you, and you can run it, and you have a Tesla or even 2 or 3 Teslas at a remote center, or maybe even at your house. And you could then do AI programming and auto labeling parenting, the human checking of auto labeling. And you could do that remote. But even in that case, people are encouraged to be cross-functional. You're encouraged to also drill metal and paint cars, etc. So even that is encouraged to be sitting on the floor in the factory with a laptop, because later that day you'll probably be loading material into robots.
Perfect. I thank you very much. Thank you very much for all your knowledge and experience. It was an honor having you today, and I will hope you enjoy the rest of the conference. Thank you. Bye.